Lesson 14.5, multiplying polynomials. The type that we're going to work with first is probably the most common, and it is multiplying a binomial times a binomial. And I'm actually going to introduce a word for you called FOIL. First, outer, inner, last. And here's what we mean by that. When you have two binomials, so a plus 7 times a plus 2. Those are two binomials. When it says first, it means the first term in each binomial, a times a. What is a times a? A to the second. You'd go to the O, outer. So as you look across the problem from left to right, a plus 7 times a plus 2, the two terms on the outside, the outer ones would be the a times 2, which would be 2a. You always put the number in front, 2a. Inner are the two on the inside when you look across from left to right. The two on the inside. So 7 times a, so plus 7a. 2a is the outer, a times 2. 2 times a, it's the blue arc. See the blue arc? The outside ones. Here, let me write this like this. A plus 7 and a plus 2. The ones on the outside, so you look at this problem all the way across, the ones on the outsides would be the a and the 2. That's 2a. That was the first term in each one. The first ones, the a and the a. The first two, a and a squared. Outer, the ones on the outsides, the a and the 2, 2a. Inner, the ones on the insides, 7 and a. And then finally, the last one in each, which would be the 7 and the 2. So 7 times 2, 14. First, outer, inner, last. Now the trick to this is almost always, not 100% of the time, but almost always, these two in the middle will be like terms. And if they are like terms, you should combine them. So you would write a to the second. What's 2a plus 7a? 9a plus 14.
Do we have to?
You do. You do. Your final answer is a squared plus 9a plus 14. That's written in what's called standard form, where you start with the highest exponent and then decrease till you get to just the plain constant term by itself at the end. Yeah, Morgan.
Why would it be 9a and not 9a squared?
Because we're just adding it, not multiplying it. Not a times a, it's just 2a's plus 7 more a's. So there's a total of 9 a's altogether. We're just, when you add, it doesn't change the exponent. Okay? You can only combine like terms. They have to be the exact same variables, and then they stay. The variables stay. Okay, over here on the right, I've got x plus 4 times x minus 9. Yes. So if we multiplied the first, which two am I going to multiply, Lindsay? X times x, which is x to the second. That's the first. Okay. Outer. You look left to right across the problem. Outer means the x and the negative 9. What's x times negative 9? Negative 9x. Okay, inner. Inner means the 4 times the x, which is 4x. And last. Last are the last two in each polynomial. 4 times negative 9. Negative 36. Negative 36. Okay, look at the two terms in the middle. Are they like terms? They are, so it's going to be x squared minus 5x minus 36. Okay, now I'm going to stop with all the colors and see if that makes a difference. 3b minus 2 times 2b plus 9. First, that means 3b times 2b. No, we're multiplying. 3b times 2b.
10b.
3 times 2?
Is 6.
6b to the second. We're taking b times b. B to the second. That's first. Outer. Outer means that from left to right, the 2 on the outsides, the 3b times the 9. So 3 times 9 makes it 27b. Inner, the 2 in the middle from left to right. So negative 2 times 2b. Negative 4b. And last, the last 2, negative 2 times 9, negative 18. The 2 in the middle are like, and they can be combined, so you would kind of clean it up and say 6b to the second. 27b minus 4b, how much would that be? 23b minus 18. 6b to the second plus 23b minus 18. Okay, one more of these. 6x plus 2 times x minus 5. First, 6x times x. How much is that? 6x squared. Outer. So 6x times negative 5. Negative 30x. Inner. 2 times x. 2x. And last, the last one in each set, so 2 times negative 5. Negative 10. So my 2 in the middle, just like all the rest, they're like terms. So I clean it up a little bit. 6x to the second. I'm in the whole 30 and I gain 2. Negative 28x minus 10. That's multiplying binomials. You'll use FOIL. Okay, you will have a couple of problems like this one where it says trinomial. I'm taking a binomial times a trinomial. So there's no fancy little word or FOIL or anything like that. It's just distributive property a couple of times. So here's what you do. I'm going to start with this C. And I'm going to distribute the C through those parentheses. So C times 2C squared. Well, the C has a 1 in front of it, so it's not going to change any of the numbers, none of the coefficients. But the C will increase because they're multiplying a C in it. So it's 2C to the third. What about when I take C times 6C? Negative 6C, I should say. Negative 6C to the second. And now I'm taking C times 7 plus 7C. Alright, I'm going to erase my arcs because now I'm going to go with the 5, and I want to show you how I do this. You can write this in one long line, but I think it would be simpler to do this. I'm going to take 5 times 2C squared. It's not going to change my letters, but what's 5 times 2? 10C squared. I'm going to write it right here. So I line up the ones that I'm going to combine later to simplify it. So 10C to the second. What about when I take 5 times negative 6C? Negative 30C. See how I write it under the C term? Negative 30C. I don't know why that is. There we go. And 5 times 7 is just a 35 out here at the end. When you do it like this, you'll have the ones lined up that you need to combine for your final answer. You don't have to do it this way. I just find that it's much easier to do it this way.
Yeah.
Want to start with the highest exponent because that's standard form. So you would have 2c to the third. Okay, what about the c squareds? I'm in the whole 6 and I gain 10. Plus 4c squared. The plain c's, I have 7, but I go back 30. So negative 23c plus 35. 2c cubed plus 4c squared minus 23c plus 35. That's taking a binomial times a trinomial. You can multiply any polynomial by any polynomial. It's just the one that's in the first parentheses. Take every term and distribute it through and multiply it with every one in the second set of parentheses and combine like terms at the end.